honors, I hope you're all having a fantastic day. Leave a comment down below on what project you're all currently working on. I cannot wait to see all of your responses. And I'm also so excited to be showing all of you how to be using data discovery with your machine learning models. For those of you new to the channel, my name is William McCann, and you're watching On Robotics, where we're using Python to learn applications of machine learning and artificial intelligence through demonstration. As always, as what we like to say, sit back, relax with your favorite snack, and let's get started, shall we? Hey, honors, this is Editing Will. I forgot to mention one thing, and that is today's video is the very first video of the data preprocessing in Python series. So I hope you all enjoyed the very first episode. There will be plenty more to come because this data preprocessing stage, as I'll go over in today's video, is a huge factor in machine learning and artificial intelligence. So now back to current me. So in the last video, not only did I show all of you how to install the Python Kaggle API, but I also showed all of you how to actually operate the Kaggle API so that you can have access to Kaggle's huge database. And for those that stuck around for taking it up another notch, we actually create our very own automated Python script that does all the steps for us. Now we have our own data set. What's the next thing? Can we start creating our own machine learning model or our own artificial intelligence model? Well, unfortunately, if I can speak correctly, that's not what we're going to be doing next. Instead, what we're going to be doing is actually going into our data set and actually discovering what are the weaknesses and what are the strengths of our data set. Also, this is really what's also known as the data preprocessing stage. However, the data preprocessing stage is really broken up into several different sections that we'll be going over in the next few videos. But what we really want to look over and discuss in today's video is how to actually look into your data and discover all those really important aspects of your data set. Now, yes, you could crack it open and look at it line by line. However, that would be very time consuming, and most chances are your data set has thousands upon thousands of lines. So really that's almost impossible. Fortunately for us, and since the Python community is so amazing, we have a whole boatload of different tools at our disposal, free tools by the way, that will allow us to essentially crack open this data set and find out what we need to find out in order to be able to create a very successful machine learning or artificial intelligence model. Before we can actually start doing some data discovery with our data set, first thing we have to actually do is import this data set into our code. What you're all seeing right behind me is called a Python console. If your IDE like mine, which is PyCharm, allows you to use the Python console, I highly suggest using it whenever you're testing out code, because I use this honestly on a daily basis whenever I want to implement a new section of the code, but I'm a little nervous that my theory is not exactly the correct theory. I want to test it out on something that's not going to break my whole code, all right? So Python consoles are honestly very, very handy to be using almost on a daily basis. So what we're going to actually be using the Python console is actually to allow us to be discovering, like I was saying at the beginning of today's video, discovering the data set to find really the pros and the cons. And the way that we're going to do this is we're going to be importing the Pandas module. Now, inside of the Pandas module, there's a really cool module called read CSV. I did a whole video on the read CSV module because it's really the easiest way to read a CSV file. But for those of you that missed that video, it's honestly as simple as just saying, oop, if I can click, I need to click on you. Import pandas as PD, and then we're going to say data equals pd.read CSV. And so at the end of the read CSV file, just like every other method within the Python language, we're going to have parentheses at the end of that method. Now within those parentheses, the input argument that we're going to put is actually the file location of the CSV file that we want to read. Luckily for us, this Python console is actually within the same file directory as that CSV file, which is the housing CSV file. And so all we have to really do is actually enter the name of that CSV file inside of those parentheses. And yes, that CSV file is actually the same CSV file that we downloaded from the Kaggle API. So we're just going to say housing, in quotations, housing.csv. Now, once we've hit enter, that all the data within the housing.csv is now taken from a CSV format and imported as a Pandas data frame. Now, using a Pandas data frame is very, very important because all the methods that we're going to be talking about comes from the Pandas module. And more specifically, all the methods that we're talking about in today's video actually come, well, in order to actually be able to use it, you have to be using it with a Pandas data frame, which is exactly what we just turned data into, is a Pandas data frame. Now, the very first method we're going to be talking about is actually called the head method. The head method is a very interesting method in the fact that when you call upon this method, you're seeing the first n number of rows. You're seeing all the data within those columns up for those rows. And really what it allows you to do is just really make sure that the data set that you're looking at, that you're essentially wanting to create a machine learning and artificial intelligence model, is actually the correct data set that you're looking at. In many ways, what you can really think about this is you're really just seeing the CSV file in table format. Right? And the way to actually call upon this method is by coming over to a Python console or a Python script, whichever one you have open, finding an empty line and just simply saying print data.head parentheses, and then when we hit enter, you're going to see the first 5 rows of your data set. This is really going to give you an idea of what is being incorporated into your data set. However, if you need to see more than just the first 5 rows, you can actually expand to see as many rows as you would like. So if we call upon that same statement, inside the parentheses of head, you specify exactly how many rows you want to see. So if we want to see 10 rows, then we just put 10 right there and then hit enter. Now, as you all can see, we have the first 10 rows of our data set. Really, the important part of the head method is just to give you an idea of what's being incorporated into your data set. Like, for instance, we can see, well, I can see that there's a majority of the data is going to be floats, and then we have ocean proximity, which is a column filled with a bunch of strings. All right. Now, more importantly, to actually get a better idea of what the scope is for your data set, what you're going to want to do is actually use another method, the info method. Now, really the best way to think about what the info method is a summary of your data set. It's going to give you a whole boatload of different information like the column names, the column types, how many rows are inside of your data set, how many columns are in your data set. But let's actually just switch over to a Python console where you're all going to be able to see me actually implementing the info method into our Python console. Now, what you're really all going to see is that implementing all the methods that we're talking about from the Pandas module is really simple to do. Just like how we were talking about with the head method, in order to actually implement the info method, we just have to say print, I gotta come up to you, I keep doing that, print data.info, alright? And then close those parentheses, and we're going to hit enter. Now, you're really all going to see how in-depth this info method is going to provide you with a summary. I really enjoy this method for a couple of reasons. First of all, it's telling you the range index, so how many entries you have inside of this data frame, as well as all the column names and how many columns. So right here, it's going to tell us that the data columns total is 10 columns, and we have longitude, latitude, house median, all that really fun stuff. Not only does all the information that the info method provide really fun and fascinating, but also there's something that's really huge that we have to pay a lot of attention to. The important information I'm talking about that we really want to keep an eye out is to make sure that the columns data type is not an object data type. So what I'm talking about exactly is if we look over at longitude, we're going to scroll all the way to the right to see float 64. Float 64 is perfectly fine. Integers are fine. Really, that's what you want because machine learning and artificial intelligent models really want all the data being provided to them to be either a float or an integer. When you look inside the info method and you see that a column has a data type of objects, that means that inside of that column, at some time or another, that column actually has a string inside of it. So that's what an object means, is that it's anything but a float or an integer, so chances are it's going to be a string. Now, the way to actually evaluate this in a much easier way, instead of going column by column by column, is actually going over to this line right here, D types. Now, what this line's giving us is essentially a full summary of what data types are being represented inside of each column. So what we can tell by this line is that we have 9 columns that have float 64 data types inside of them, as well as we have 1 column that's an object column. So therefore, since that column is an object column, we really want to go back into the D types and look at each line and find that object. We already have an idea from the head method, but we don't want to jump the gun until we actually have the confirmation from the info method that this column is actually an object column. And the column I'm talking about is actually ocean proximity. So based off of that theory, what we're going to actually do is come back over to the info method, and we're going to look for ocean proximity, and we're going to look over to the right. Our observation and our theory was correct that the ocean proximity actually is the object type, the object column. We don't want to jump the gun and assume that everything inside of ocean proximity is nearby. Instead, what we're going to do is use a method called values count. Now, what values count does is it returns the amount of times each specific value was called upon inside of a column. The way to actually call upon this method is, you guessed it, we're going to be going back into the Python console and typing in print data, and then we're going to do the values count. So let me click on you. print data dot values count. Now, if I haven't said this before, honestly, if you want to get a really awesome autocorrector for your IDE, I highly suggest Tab9. There'll be a link to it down in the description bar down below. This video is not sponsored by them whatsoever. I just think their product is fantastic. And as soon as we have values count and the data and all that fun stuff inside of that print method, we can actually come over and hit enter, and it's going to show us all of the information we need to see. So we're going to see that, oh, I didn't specify exactly which column. Maybe. So the way to actually think about how a Pandas data frame operates and how you're able to call upon each column is much the same way that you're going to be able to call upon key terms within a dictionary. So what we're going to do is come back over to data, and we're going to type in, what is it, ocean proximity? Once we have that all set up, I'm going to come over here. I just literally copied and pasted from here and put it in there. And once we have that, we're going to hit enter. And we're going to see all the count of every single term that was inside of that one column. And as we can see, greater than 1 hour ocean was called upon 9,136. Inland is 6,551. So what we can see, honestly, is that there is more than one term that's being occupied inside of this column, which is very, very important. And honestly, this information is going to come in very handy later on in this series of data preprocessing. But now that we have an idea of what we need to accomplish in that later on video, we're going to continue on to the next method, which is the describe method. Now, unlike the info method, the describe method is really giving you a lot of the statistics behind what's going on in your data set. It's something that's very handy to understand, so you understand, like, for instance, it's going to show you the mean values of each column, the highest value inside each column, the 25th percentile. And I'm saying all this like you all can really visualize this. So why don't we actually go back to a Python console, and I'm going to actually use this method and explain it that way instead. So we're back over at the Python console, and I just real quick did the whole print statement for the describe method. It's the same exact idea as all the other methods that we've talked about in today's video. Like, I'm just going to highlight it real quick. It's just print data describe, and it's going to show you a whole boatload of great information. Like, how many values are inside of that one column? What is the mean value for that one column? What is the STD value for that one column? The min value for that one column. It's going to do it for each individual column. Now notice, ocean proximity is not in this describe method. It's not in this table, really just because this describe method is only showing you all the needed information for any of the columns that have integer or float values within them. Ocean proximity, like we just went over, is actually an object column. We're going to do some really cool stuff to fix it into something that a machine learning model will really enjoy and actually want it to be, but that's in a later on video. And honestly, I hope all of you can see that within all these different methods, it's going to really give you a really good idea of what's going on inside your data set, allowing you to be able to predict a very interesting and very successful machine learning or artificial intelligence model based off of all the information that we've learned from today's video. And others, that's all I got for today's video. Yeah, you all know me. Would I really leave a video where I have to be plugging in everything? Of course, we're going to take all the information we just learned, put it into a script, and get the whole thing automated. I mean, isn't that what's so awesome about Python? You can get some computer to do all the hard work. So what we're going to actually do to start off by having this Python file do all the hard work is by first specifying exactly which module we're going to be using inside of this script, which is going to be the Pandas module. Now, we have the Pandas module for two reasons. The first reason is because of how, like I've been saying throughout this whole video, all the methods we're getting all of our output text from is actually from the Pandas module. Now, the second reason we have this Pandas module inside of here is actually to make sure that all the information being inputted into this class is actually a Pandas data frame. Because if the data is not a Pandas data frame, there is no basis for this actually to work, because we need the Pandas module and we need it to be a Pandas data frame, which is exactly why we have this other class right here, this class not Pandas data frame exception class. Now, the only real reason for this is because later on inside of today's code, we're actually going to be importing a logic check to make sure that the information being provided to this class is a Pandas data frame. And if by some chance that the information being provided to this class is not a Pandas data frame, this error is going to be called. Now, once we have this all set, we can actually start having the classes. It's going to be doing all the fun stuff. The data discovery class And honestly, this class is specifically designed to be a command line tool or a terminal tool, really just so that you're going to be implementing some sort of pandas data frame from your script, and it's going to be popping out all the information that we've been going over in today's video, which is why this class is going to look a lot like what we got up on the screen right now, where we're going to have df as our input argument for our init method. Then on line 7, we're going to double check to see what instance of df is. We want to make sure that df is actually a pandas data frame. If it's not a pandas data frame, we're not going to be able to use any of the modules that we talked about. Not modules, methods that we talked about in today's videos. Once we are sure that df is actually a pandas data frame, then we can start initializing the rest of this class, which is going to be self.df is df, well, equal to df. And then self.head is going to be calling upon the self.head method of the pandas module. However, the difference between that method and the method that we're describing today is actually this method is going to be automating everything. It's going to be giving you some sort of feedback. And the same thing with info. We're going to be using a combination of values as well as the info method to actually be able to determine if there are any values or columns inside of your data set that have an object type inside of it. All right, so we're going to get to all that fun stuff in a sec. And then describe is just going to be importing. It's going to tell you, hey, we got the describe method coming up in a little bit. Would you like to go through it? If you hit yes, then you're going to see the whole output of the describe. Now, the self.isNull is something that I'm not sure if Pandas actually has a method like this where it tells you, A, what column has null values inside of it, and inside that column, how much of the data is actually null. Being able to actually tell what values inside of your data set is null is very, very important, because you're going to have to do some really cool stuff in the data preprocessing stage that we'll go over in a few videos from now. But it's something that we really have to keep track of, and I want to be able to have access to telling which columns have null inside of it and how many of those values is actually null. All right, and then afterwards we're going to say print. That's all the information I got for you. And then if this instance is false, we're actually going to be calling upon that error that we were talking about earlier on. So we've came over to the head method that we're going to be creating. Remember, the whole purpose of any of the methods that we're going to be going over inside the script is really to help automate all the other methods that Pandas has already helped us out and created for us. So that's why we're going to say choice equals int, well, not int, choice equals input. Enter yes to view the output provided by the head method. We're giving the user the opportunity to say, no, I don't really want to see the head method, but chances are they're going to want to see what's being populated by the head method. That's when if choice.upper equals yes, meaning they want to see what the head method is actually providing, we're going to go into a print statement saying the default amount of rows that you are able to view is 5. And then we're going to go into a try except method where the user is going to have the ability to say 5 rows is fine, or enter the amount of rows that they want to see. Nothing really too interesting besides what I just said going on this line. Really, the other interesting thing is if if they hit enter instead of entering some value over here at values, and it causes the except to come up, we're going to say values is equal to none. This is going to come in really handy because it's easier to differentiate between a variable that is none and a variable that isn't none than anything really else, unless we want to make values some sort of Boolean statement. So when we come over to this if statement, we're going to say if values is not none, meaning the user actually decided to enter some sort of value inside of this values right here. We're going to call upon self.df.heads, and we're going to pass in the values of values, all right? And we're going to print out that whole head statement from the Pandas module. Then if by some chance they say, well, they just hit enter, meaning values is actually none, we're going to just get the regular default amount of rows from the df head statement. All right. The reason why I said if values is not none instead of if values is none is because it's easy. Well, if you did that, you said if values is none and values is actually an integer, you're going to cause an error right here. That's why I did this. So that's really all that's going on inside this head method. The next thing that we're going to be coming up is actually the info method. And really what we're going to be doing is calling upon Pandas info method, as well as on our own, we're going to evaluate each column's D type, allowing us to be able to determine if the column's data type is sufficient for a machine learning or artificial intelligence, or if the column's D type is an object. Then the software is going to then provide the user with the information that, hey, this column has to have some sort of manipulation done to it. This is why, and all that stuff. And it's going to call upon the values count. And honestly, what it's going to therefore giving us a script that looks like this, where we have choices equals input, enter yes to view the output of the info method. Then when the user does enter yes, we're going to go into this if statement where we're going to be printing out the values from the info method. After that, we're going to create our very own list called objects list. Now, this list is going to keep all the names of each column that has an object associated with that column. And the way we're going to do that is we're going to say for I in self.df.columns, allowing us to have access to each individual, the string value of each individual column. And we're going to say if self.df at key term of I dot dtypes equals objects, we're going to therefore append that I to objects list. Afterwards, we're going to say if length of object list, meaning there's actually some sort of data within objects list. So if the length is 0, that means it's an empty list. If the length is greater than 0, therefore it's not an empty list, and we want to evaluate that empty list. Well, we want to evaluate that list. Therefore, we're going to call upon a print statement, and we're going to say the columns called \n, causing the script to therefore print on the next line, and we're going to print out the whole list of the objects list. After we do that, we're going to do \n, and actually this is / not backslash. Therefore, I have to switch that around real quick, and then we're going to say our object types. After that, we're going to ask the user, hey, do you want to do anything with these columns? If the user does enter yes, we're going to go into this while loop where we're going to say we're going to print self.df of objects at count, because we can create this very own count, and this is count's going to go through the objects list, therefore allowing us to go through each individual column, calling upon from the values count. Once each column is done and the user's been able to evaluate what the output's been, we're going to ask the user, well, first of all, before we ask the user, we're going to say if count is greater than or equal to the length of object list, because we're counting, each time this while loop goes through, we're going to say count plus equals 1. Once that count is greater than or equal to the length of object list, we're going to break out this whole while loop, because there's really no other information inside object list, so what's the point of continuing on? Afterwards, the user is also going to have the ability to say, hey, I don't want to continue on. I've got an idea of what needs to be changed, so I'm going to say no. So when values equals no, we're going to pop out of this, or any other value besides yes. Therefore, allowing us to have a really cool info method, and really we continue on to the next one, which is going to be the describe method. And just like the other two methods that we talked about, really the describe method is really trying to emphasize and automate the process of using pandas describe. So what we're going to do right here on line 46 is just like how you normally call upon a method within Python. Then the next line we're going to try switching it up a little bit by saying we're going to call it print statement, saying the next table you will see is from the describe method. Then we're going to say choice equals input again, enter yes to continue if the user does enter yes. We're going to therefore print out the describe method for the current data frame that we are working with. Now the next method that we're going to be talking about is going to be the isNull method. This is a very, in my opinion, being able to tell what values and what cells have nulls inside of them are really, really important, so you don't break your machine learning or artificial intelligence model, therefore causing you to have a programming headache. So what we're going to do instead is create this method to help us along. And I don't really know if Pandas actually has their own version of this, but we were able to we'll go into the Pandas module and pull out some stuff to actually help us create this module, therefore allowing us to have a method that's going to resemble this. What we got up on the screen right now. Now, this isNull on line 51 is going to be very similar to all the methods that we defined in today's video, where we have a choice variable saying, hey user, you have a choice to say yes or no to viewing the output of this method. When the user does enter yes, which is what we got on line 53, we're going to create a isNull empty list. This isNull on line 54 is very, very important for the rest of today's code, well, the rest of this method, for several reasons, as you all see in a couple of seconds. Once we've defined this empty list, we're going to create a for loop saying for I in self.df.columns. Then after, we're going to create an if statement saying self.df at the key term equal to the value of I at .isNull.values.empty, well, not empty, any. Therefore, we're going to be creating a Boolean statement, where this statement really is just going to look inside each column. If there's any value within that column that is set equal to null, therefore this value is going to become true. When this does become true, we're going to say isNull.append at I. When it's false, it's just going to skip right over this column. Right after this, I'm going to show all of you another way to tell if a list is empty or not, by saying if is null is not equal to empty brackets, therefore meaning there's some sort of values within this is null list. We're going to print out this fstream statement saying your data set has the length of is null, columns with null values. Would you like to see the column names as well as the amount of nulls values within that column? And then we're going to have a column set equal to an input saying enter yes to do so. If this value is uppercase yes, then we're going to say for I is null. We're going to say print, and we're going to use another fstream where we're going to say in column I, so therefore the column of value I that we create for that is null, there are blank self.df at index will key term of I.isNull.sum. So this is going to turn that value into an integer value, counting up all the null values within that one column. And then we're going to finish off that print statement with cells with null values. All right, analysts, thank you all so much for watching. Honestly, the script was so much fun to create and do all this research. So if you want to get hands on this, go ahead and check out the link down in the description bar down below. I'll send you over to my GitHub link. I know I didn't show you all this script running. Don't worry, stick around for the last few seconds where there'll be a high speed of me running this code. As always, if you're brand new to this channel, please do consider becoming part of the Island community, where we're using Python to learn applications of machine learning through demonstration. As always, happy coding. I'll see you all in the next video, Islanders. Bye.